Hey, hello guys. My name is Kalyan and I have been associated with Edureka for quite some time now. It's been more than 3.5 years. Housing price prediction using machine learning. This is the topic of today. These are some of the things that we have for today's session as a kind of agenda. We'll try to understand about machine learning. We'll try to understand the types of machine learning. We'll quickly jump onto the problem statement that we have. Okay, and then we'll try to understand how does a data science solution workflow look like and what could be the possible tools and frameworks that we could possibly use. Okay, so when I say machine learning, these are certain bunch of statistical methods. Okay, these are bunch of statistical methods which rely on certain set of data, okay, which it analyzes, okay, and which it actually converts it into a kind of function with the help of which it builds a model. Okay, when it builds a model, with the help of those model, we are also able to make certain predictions out of that. And during this entire process of doing these few things, it essentially moves towards, or it essentially moves towards the phase of artificial intelligence. Okay, so in a sense, when it is able to make certain predictions using certain set of provided data, it embeds certain amount of intelligence which is artificially provided to it. Okay, it analyzes different patterns of data in which is provided during the training time, and from that particular training set of data it actually works out a particular model which could be used to make further predictions on that. Okay, when it comes to machine learning, there are certain terms which you need to be very much clear about. When I speak about machine learning, these are statistical techniques. Okay, so you could use machine learning irrespective of the platform or the tool which you have. Okay, to give you an example, I could build a linear regression model, which is a kind of machine learning technique. Okay, I could build a linear regression model on C++, could build it on Java, I could build it on MATLAB, I could build it on Octave, I could build it on R, Python, SAS, SPSS, Azure, GCP, AWS, just to name a few. Okay, the techniques would always remain the same because these are statistical techniques. Okay, the only thing that would change is the way that you would be interpreting these things when you are using different tools. That's one very important thing which you need to know. Okay, other thing is, when I speak about machine learning, these are certain algorithms. Okay, these are certain set of algorithms which you do not have to specify what needs to be done. They are smart enough to analyze the data. They are smart enough to understand the patterns, and they are also smart enough to make a particular predictive function out of the training data which is provided. Okay, there are only three types of techniques, guys. Okay, when I say there are three types of techniques, these are supervised learning, unsupervised learning, and reinforcement learning. For today's webinar point of view, we have the topic of webinar is predicting housing prices, and for that we are going to focus mostly on supervised learning. When I say it's supervised learning, it's unsupervised learning, it's reinforcement learning. Let's try to concentrate on supervised and unsupervised learning as of now. It stems from the fact that there is something which we call it as a supervised data. Okay, so when I say supervised data, it is essentially a label data. Okay, what is a label data? I'll give you an example. Let's say for all the participants that you have in this particular uh, in this particular session, I somehow managed to get your historical medical information. Obviously, you have shared with me voluntarily, and with the help of that, let's say historical medical information, I also get to know what kind of say disorders or diseases you might have been affected. Okay, so let's say there is a participant. Let's say there is a particular observation. Okay, which tells me about the fat content, the blood pressure, okay, the let's say what else? The blood pressure, the count of white blood cells, the red blood cells, and finally, I have a particular information which says whether this particular person is, let's say, anemic or diabetic. Could be anything. So I have a set of observation with the help of which I can conclude whether a particular person is, let's say, diabetic or not. I'm giving a very fictional example, guys. Okay, you do not have to take these things into your heart. Okay, so I have a set of observation. Let's say I have the height, weight, I have the amount of fat content, I have the amount of protein content, I have the amount of carbohydrates, I have the amount of blood pressure, white blood, WBC and RBC content, all these things that I have. And with this information, I prepare a particular data which will tell me at the end of each observation whether a particular person is diabetic or not. So at the end of this exercise, let's say I'm getting a million observation. So when I say million observation, these are essentially rows. So a million rows, and I have 15 columns. Okay, so let's say these are the parameters which I have actually collected from you. So with those 15 parameters, I will be collecting those information, and on the 16th column, I will get to know whether these particular observations are diabetic or not. So the responses could be diabetic, non-diabetic, diabetic, non-diabetic, and so on and so forth. But these are the only two options that I have. So if I have this particular option, I could call this particular data set as a supervised data because it has certain labels. So that whether the particular person was diabetic or not is something which you call it as a label, and rest of the variables which is leading to this label is something which you call it as an independent data. Okay. Now that label could be either discrete or continuous. It could be, let's say, the amount of rainfall which is happening over a period of time in a particular geography. That could also be an example. So in that case as well, it is a supervised data. Hence, the techniques which are used on those kind of data set is something that we call it as supervised learning techniques. When it is unsupervised learning, which is applied on unsupervised data, you won't be having that particular labeled information in your data. Okay, if you won't be having label information on your data, you would not be able to carry out the similar type of algorithms which you'll be doing in your supervised learning. Hence, the set of algorithms which you'll be going through in supervised and unsupervised learning are totally different. Now, what is reinforcement learning? This is something which is totally different from supervised and unsupervised learning. Reinforcement learning is mostly the kind of learning which happens when you learn from an environment. You have a particular action to be performed, you have a particular entity who is going to perform the action, and the entity will learn from its surrounding and understand whether that action has been correctly performed or not. Okay, a typical example of reinforcement learning is something which is mostly used in self-driving cars. Using the surroundings that we have in our self-driving cars, the car self-driving code or the self-driving entity understands what is a particular decision that needs to be taken. Okay, so let's say a particular car is driving at a very high speed with a particular person seated on that car. Let's say there is a particular red light which you are about to cross unknowingly, and there is a person who is in front of your car. So whether you should be saving that person who is in front of your car, or whether you'll be applying a hard brake which might cause the damage to the person sitting in that car. So these are certain kind of situations which might arise as in when you'll be working in the area of reinforcement learning. Okay. So these are the three different types of techniques that we have in machine learning, and these are the only things that we have. Okay. Now, depending on which particular technique you're going to use, there are different types of techniques inside supervised and unsupervised learning and reinforcement learning as well. If you want a definition of supervised learning, you could say that supervised learning is a type of machine learning algorithm that uses a known data set. So when I say known data set, you just try to correlate with the example that I have given. We had independent variables, 15 independent variables leading to one dependent or label variable, which was whether the particular person was diabetic or not, or the amount of rainfall. It could be anything depending on the data that you have. Okay, so that's what we call it as a labeled data set or a known data set. Okay, similarly, in case of a unsupervised learning, you could have it's a kind of machine learning algorithm used to draw inferences from data set consisting of input data without label responses. See, the term label responses is mentioned over here. Okay, for example, when your kids are taking decisions out of their own understanding, this is a kind of a learning which you call it as an unsupervised learning. So anything which does not have supervision, okay, is something which you call it as an unsupervised. Similarly, we have discussed about the example of reinforcement learning. Let's say there is a particular kid and a dad having a conversation on a particular action that is being performed by the kid. The kid isn't aware what is good and bad. The dad is there over here to help the kid to understand whether the action that has been performed is good or bad, and accordingly there could be a particular punishment or a reward depending on the consequences of the action. Okay, that's the essence, I would say, of reinforcement learning that we have. Okay. Now, what's the problem statement that we have? Okay, now in this particular in this particular session of today, we are going to predict the housing prices. Okay, now when I say housing prices, give me a moment. Let me show you the data. I should have actually opened this for you. I haven't done that. So the housing data is here, and this is the housing data that we have. I hope all of you are able to see my Excel file, guys. Yeah, I could see that. I'm showing an Excel file, guys. In case anyone of you is not able to see my Excel file, do let me know. I'll try to see what could be done. Now, if you notice here, there are certain variables which we have in the data set. We will try to spend some time to understand the data. Okay, let's not focus on what is there in the code and what is not there, because that is something that you'll eventually learn over a period of time. But it's really important to understand how you could frame a particular problem statement and how you could deduce your way out to understand which particular technique needs to be applied. Okay, now every particular problem that you are going to solve in the area of data science would be having something which we call it as a problem statement. Okay, that is where that is the source of any particular algorithm, that is the source of any particular code that you're going to write, any particular inferences visualization you're going to make. Okay, so what's the problem statement that you have? The project aims at building a model of housing prices to predict median housing prices in California using the provided data set. Okay, now what we have over here is a bit different. Okay, in this particular example, what I'm going to take is I'm going to take a housing data set, but this housing data set would help you predict whether a particular house would have ocean proximity or not. And if it has an ocean proximity, what would be the ocean proximity? Whether it's an island, whether it's a nearby, whether it's a near ocean, inland, or less than 1 hour of ocean. Okay. Now, how have I built this data set, or how was this data set originally built? There is something called as a longitude, there is something called as a latitude. So this essentially refers to the longitude and latitude of a particular place. Housing median age. So the median age of the houses that we have, how many total rooms we have in the house, how many bedrooms we have, what's the population we have, and the households that we have, and the median income and the median house value. So these are some of the observations, okay, which will help me understand whether a particular, or like what could be the proximity of that particular house. This is what we call it as a label data. These are essentially variables that we have in my data set. Okay, these are the variables, and just hold on, guys. This is my dependent or labeled, or you could say target data. Okay, it's known by a lot of names, and this is what I have as my independent or response data. Okay, so my count is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 variables over here. So 9 independent variable and 1 dependent or target variable that I have. So my objective is to use this particular data set. By the way, these are all observation, guys. Okay, and these are all columns of variables. My objective is to build a particular model, okay, which will be able to predict the ocean proximity, provided I share this information, provided I share a new set of independent values. Okay, so I should know whether it is lying near bay or island or near ocean, or whether it's an inland. So let's say that's the objective that I have for today's session. Okay, so my target response or the target variable that I have here is what I will call this as a categorical target variable, because these are categorical in nature, these are not numeric in nature. Okay, how many categories do I have? I have 1, 2, 3, 4, and 5. I have 5 categories over here, and they are well represented as well, as you could see. So this is 0.1%, this is 11%, this is 12%, this is 31%, and this is 44% that I have. How many observation do I have for this particular data set? I have a count of 20k observation. So 20,000 observation I have. So 20,000 cross 10 variables which I have, and out of those 10 variables, one of them is my labeled data, and the rest of them are unlabeled data. Okay, or independent data. That's the data set that's the data set that I have. Okay, and this is the problem statement which I have. Now, how would I proceed ahead if I have these two information? Okay, usually you'd be having with these two information, or at least you'll be having the problem statement at your hand, so that you get to know what is it that you want to actually do. So if you have a close look at this particular workflow slide, what do I have over here is, I have something called as a data, okay, which is my data set. Now what will I do is, I'll divide my data set into two parts. Okay, how many observation that I had? So I had 20k observation, and let's say I'll take 80% of my data, which will be around say 16k. Seems like this will take a lot of time. So let's say I'm taking, I want to take 80% of my data. So 80% of 20k would be around 16k. So I'll take somewhere over here. Okay, so these are the variables which I have, and what I'll do is, I'll just make a different color for this. Okay, so this is the color that I'll be putting here. So this is my training data, and this will be my test data. So I am intentionally separating. So nice. Yeah, I'm intentionally separating my data over here, and what I'll do is, I've separated in such a way that I have a larger chunk of my data for building my model. This is something that I have essentially done. So I'll build my model on the blue data, and I'll test my model on the orange part or the amber data. Okay, this is something that you'll be doing, which is something that is represented here in this particular slide, when you could see training data set and testing data set. So essentially it is divided in the ratio of either 80-20 or 75-25 or 70-30, depending on the number of observations that you have. But the idea over here is, you need to have as much of data as it is possible for your training data set. Okay, so usually it is around 80-20. So I have 80% of my data set here in the training data set, and 20% in my testing data set. Now on this 80% of my original dataset, which is my training dataset, I would be choosing a particular algorithm, and I'll be working with that algorithm. Now, how do I choose this algorithm? When I'll be choosing this algorithm, I'll have to make sure that I know what is my dependent variable or the target variable. And since this is a supervised algorithm, I could choose any of the supervised technique. And in this particular case, it will be a classification problem, since the target variable is categorical in nature. Okay, I build my algorithm. What I'll do is, I'll be evaluating my algorithm on my testing data set. Okay, I'll check the results of my evaluating algorithm. If it is fine, then I'll be moving ahead. Otherwise, I'll make sure I'll try out a different algorithm. Okay, over this exercise, I'll be doing a lot of data pre-processing techniques. I'll also try to understand what are the variables which will be important for this particular model. These are some of the things which I'll be also doing. But once I finalize my model, once I build this model, and once I get a satisfactory result after evaluation, I would be using this particular model for deployment, and I'll be deploying this particular model to the production environment, and I'll be using this model for making predictions. Okay, so this is what I'm going to do, and very similar thing I'll be also showing you when I'll be working on the hands-on. Okay, I'll not be directly moving on to the hands-on. I'll just cover the slides that I have. So as in when I'll be building this machine learning algorithms, there are a lot of things which we'll be using. Okay, now when I say I'll be using a lot of things, I'll be using a lot of libraries to make my life simple and to make everyone's life simple. There are a lot of libraries that you have in Python. Python is an open source programming language. It's one of the most easy to learn, and it's one of the most widely spread programming language. And as you could see, there are different libraries that you could use for your day-to-day purpose while you are working on data science based project. 𝐶born, Matplotlib, and to some extent pandas are something that you could use for visualization. Pandas is mostly used for reading the data. NumPy is for numerical calculation. Jupyter is the IDE on which you would be writing out the codes, integrated development environment. And scikit-learn are the set of or the family of libraries which you'll be using for building a machine learning algorithm for understanding the accuracy of your model and things like that. Okay, these are some of the things which we are going to use. And now I'm going to move on to the hands-on part. So this is what I have over here. Let me save my file. So I have shown you this particular dataset, the housing dataset, which is something that is located in this particular folder. And I have tried to understand what is my working directory. So if I work this thing out, I'll be getting my working directory here. Okay, so this is the working directory that I have. And this is exactly where I have my dataset stored, as you could see. Okay, so I'm going to use that dataset to build this particular model. But before that, the very first thing that I'm going to do is I am importing the set of libraries which I would have to do to build the model. Okay, now I'm reading once I have I know well in advance that these are some of the libraries that I'll be needing. So what I do is see, basically I know I'll be needing NumPys and pandas. I know I'll be needing say Matplotlib and 𝐶born. So sorry, 𝐶born, and I also know I will be needing scikit-learn. As and when I'll be needing certain things like, let's say, simple imputer, label encoder, standard scalar, I'll be adding over here. Okay, so these are some of the basic things which I know would be required, and hence I have jotted it down in one particular cell. By the way, these are cells, and this is the Jupyter Notebook interface that we have. If you are not aware about this, you can actually try and install Python. It's an open source programming language, so you don't have to worry about that. You could download it and install it, and once you install Python on your system, you'll be able to use Jupyter Notebook. Jupyter Notebook is one of the IDE which could be used for building machine learning algorithms. There are a lot of things which you could use, like Spider, PyCharm, and things like that. You could also use Visual Studio for that, and there are a lot of options available. But the point is, we are reading the data here. How do I read my data? I'm using my pandas library, and I'm using a particular method called as read.csv. I know read.csv is used for reading dataset which is having a CSV file. That's the reason I'm using this. This is something that you may not understand, or you might need some time to understand if you are a newbie in this particular field. For the people who already have some exposure to these things, it would be pretty much simpler for them. They know if it is an Excel file, then this is not going to work. It will have to be a different command that you'll have to write. But essentially, it will be something that is included in the pandas library. So what do I have is, let me show this thing to you. And in case some of you are still wondering what is PD, it's a kind of alias that I'm using. So you could see here, import pandas as PD. So I'll be using PD instead of pandas because that's convenient for me. Okay. So what I've done is I've done PD and I've done a dot and I'm doing a tab. When I do a tab, I'll be getting a drop down. Oh, what happened? Supposed to get a drop down here. Okay, just okay. I'm not sure why this drop down is not working. So what you could do is, ideally this works. So you could just type the alias and dot and just type the tab key. Okay, I press the tab key and you'll see all the options that you could find inside PD for reading CSV file, for reading Excel file, for reading PDF file, and things like that. Okay, this is something that you could do and try to understand what is there inside this pandas library. Or otherwise, what you could do is what do you mean by pandas is different? Okay, probably I haven't done this. Just hold on, this is still running. As you could see, this particular dot over here. What happened? Pandas isn't defined. This is what we have. See, this is the entire documentation that you have. Okay? You can get to know what are the package contents. You can get to know what are the functions that you have, and this is something which we really like usually do not use this thing. But if you need further understanding of this, we go for this pandas documentation. So you can Google this thing. The very first thing that you'll be getting is the documentation that you have in pandas, and you can get to know what are the different things that you have inside pandas, and which you'll be able to use it over here as well. Okay, hopefully this is working. Yeah, so I have the API reference. Moving to the API reference, and you could see the host of functions that you have for extensions, for plotting, for styling, resampling, group by, date offsets, CDs, input, output, a lot of things. You get inside all these few things, it is a dictionary on its own. See, there are a lot of things inside general functions. There are a lot of things. So these are some of the things which you could also go through. Okay, this is the very first thing that you'll be getting whenever you are going to Google pandas documentation. Okay, let me quickly run this so that you could see the outputs as well. Okay, now I have read this particular data set. Now the next thing that I'm going to do is I'm going to understand how my data set looks like. So what would I be doing? What I have done over here is I'm trying to use housing.shape, which tells me how many rows and how many columns do I have. I'm trying to understand what are the columns that I have in the data set. Okay, so these are the columns that you have in your data set. Now you might be wondering why we're doing this over here. We have always seen the CSV file, right? Usually, when you are actually connected to, let's say, your databases where your files are very large, it is actually not advisable to open these files to go through each and every columns. So in such a scenario, it is really helpful if you could call these things from Python without even having to without having to open that file. Because if you open that file, it will take some time, it will consume some memory, and it can also become slow. Okay, this is the preferred way which data scientists usually prefer to do that. Is PD standard? No, PD is just an alias, guys. See, I'll show you. Okay, this is still running, so I may not be able to show you right now, but I'll definitely. Okay, it's fine. So I'll show you one thing. Who was the guy who had raised this question? Okay, Liz. Okay, so is PD standard? No. So what I'll do is I'll make this as Liz. So I'll import pandas as Liz. I'm executing this, and here when I'm going to read the file, I'll be using Liz instead of PD. So you could say I'm still able to read the file. Okay. So these are just aliases that I'm using. You could use any of the aliases as you like. This is a normal convention. People have been more comfortable using PDs. That's the reason by default. This is something which is also coming to my fingertips, I would say. Okay. So what next? I am trying to have a look at my data. These are different functions that you could see. Head is a function which tells me the number of the first 6 observations. The different types of what are the different types of variables that I have. Whether it's a floating variable, whether it's an integer variable, whether it's integer 32, 62 object type. This is something that you'll understand once you understand about the data structure that Python understands. Okay, a bit of understanding about data structure of Python, data structure and data type would really be helpful. Okay, now the next step that I'm going to do is I would be trying to build insights from my data set. Okay, I'll try to use all my independent variables and dependent variables to see if there exists any kind of relationship. I'm using a scatter matrix over here. The next thing that I'm doing is I'm plotting a histogram. As you could see, these are all variables which I'm using: longitude, latitude, housing, median age. I'm trying to see how this data are distributed. Okay, accordingly, I need to take necessary action. I'm building a correlation matrix, okay, which tells me how these variables are correlated. Believe me, guys, correlation is really very important when you're building a model. I'm also doing a heat map. Okay, now if you are asking whether we need to do all the steps or these are mandatory steps, the steps are mandatory so that you gain insights from your data, which will be something which will help you understand your model output better. But what are the things that you have to apply? Something that is your choice, okay, and is something that you will develop over a period of time depending on the experience that you get. Okay, I'm trying to find the outliers using this user defined function, and I'm trying to impute those outliers as well. I'll get these outliers. I'm imputing the missing values. Okay, I'm imputing missing values. I'm finding how many missing values we have. Okay, and I'm doing different sorts of initial analysis, which helps me get a better idea about the data sets. Now, here is exactly where I'm splitting my data. Okay, as I said, 80% is something that I'll be using for training, and that's the reason I'm splitting this into 80% and 20%. As you could see, this was my original data size. Sorry, no, this was not my original data size. Original was around 20K. Okay, I've split this into 80%, and this is what I'm getting as my training data set. Okay, and this is my test data set. Okay, now in the training data set, you could see that there is X train and Y train. This essentially means a set of independent variables and dependent variables. Now, we usually standardize our data before we build the model because this helps in initializing this machine learning models. This is one of the standard practices that we do. Okay, so this is something that is preferred. If you're doing this, you'll be achieving better results. Just hold on, guys. Let me just check one thing. What is the variable which they're taking here? So I think they're converting this into median housing value. Okay, fine. So just one small correction over here. What essentially they are predicting over here is the median house value. So they are predicting this particular variable over here. Okay, this is not the target variable. Let me make this correction. This a bit. So I'll cut this. I'll paste this here. Oh, okay. This solves the problem. My target variable is actually numerical in nature now, so I could apply regression technique and median housing value. This is how it is. This is what I am trying to predict, and everything remains the same. It's just another example that I have here. Let's move on to the data set. Sorry, let's move on to the code file that I have. So I'm splitting my data set over here, and then what I'm doing is I'm checking the shape of my data set. I'm checking the shape of X-train data set. Okay, these are not mandatory. I'm just putting it over here for your ease of use, actually. Okay, now I would be performing linear regression over here. I'm calling a basic linear regression. How am I calling this thing? If you notice, I have already called the necessary library for linear regression. Okay, I have linear regression, I have decision tree regressor, I have random forest regressor. I'll just be showing linear regression for this particular session. You could go through the course that I have for decision tree regressor. So I'm calling the linear regressor here. I'm fitting my data. So I'm essentially putting my training data. You remember the 80% of my data which I had planned for building my model on? This is what I have. So this is a way of doing this: linear regression model dot fit. So fit is the instance over here. And once I do that, I would be able to make predictions as well. So here, the model building steps is actually over. This is a very basic linear regression model, which is not having any kind of parameter of its own. If you'd really like to understand about linear regression parameters, you could check the documentation. Again, the very first link will help you understand the scikit-learn documentation for linear regression, wherein you could use all these necessary variables. Okay, if you could see, I have used only one of them, which is njobs, and that is this one. Okay, it essentially tells you how many cores you need to use, okay, but this is not relevant here. So once I have my training data ready, Okay, remember this is my train data. So what I'm doing is I'm predicting, I'm using my test data on the model that I have built here, and I'm making some predictions. When I'll be getting those predictions, I will be already having my test data and those necessary responses. So I'll be making necessary comparisons. So this is exactly what I'm doing. So the blue lines are the actual data. So when I say actual data, it is essentially the amber ones. Okay, whatever amber values you could see over here are the blue ones in the graph. So these are the true values, and the red ones are the predicted values. So whatever the model has predicted on these few instances. So what we are doing is, I know these responses, hence I'm trying to test out how my model is going to perform. Okay, that's what I have done. And this is how the prediction looks like. So if you have a close look at this particular plot, how to interpret this plot, you'll see there are instances when the predictions are a bit closer, when it's very close, and when it is far apart. If you are having a lot of instances where your predictions are far apart, it essentially means that the model that you have developed is not very robust, and you might like to improve upon this model. Okay, but having said that, we have done this exercise. Now I am going to find the accuracy of my model. Whatever model I had built, I'll try to find the accuracy. And when I'm finding accuracy for numerical values, I use a particular concept called as mean squared error. There are other metrics as well. I have MEP, mean absolute percentage error. I have MAE, mean absolute error as well. But mean squared error is something that we usually prefer. Okay. So I'm building this accuracy matrix. I'm building the training accuracy, and I'm building the test accuracy as well. Okay, the test accuracy is something that I'm more concerned with, which is this one. And I could see the value of RMSE as 71147, which essentially indicates that this is not a very good model, which is also substantiated in my training prediction. But one thing that you might like to understand is the test prediction or the actual prediction is higher than the training prediction. Okay. Now, as a next step, what I'm going to do is I'm going to try out different algorithms. Okay. So this is something that you could see, and over a period of time, you'll see that we are getting better results as in we are choosing different types of algorithms over here. Okay. So this was all about the things that we were supposed to discuss in this particular session. Thanks a lot, guys. Have a good day.